Yeah, okay. Maybe we should get going. Well, since we only have a very few people, maybe we do a quick round of introductions. So I'll start. So I'm Michael Ott. I'm working with the Leibniz Supercomputing Center here in Munich in Germany. I'm working mostly on the energy efficiency part of HPC operations, and then a big part of my work is also on monitoring. So where we have developed our own monitoring and data analysis framework, DCDB, data center database. Yeah, and then somehow through these activities, I also became involved in the energy efficient HPC working group, where I'm now also leading the operational data analytics team. Okay, so who wants to go next? Maybe Kathleen, sorry.
Yeah, sure. I'm Kathleen Shoga. I'm from Lawrence Livermore National Laboratory. I lead one of our monitoring efforts there, doing the HPC systems monitoring. And I'm also involved kind of with the power research related space. And so that's how I've ended up in kind of this area as well.
Okay, Masaki, do you want to go next? Is Masaki your first name?
Yes. My name is Masaki. I'm a kind of infrastructure engineer. So, but I used to be performance engineer. So last year I started to study facility monitoring something system. So I'm curious ODA something. That's it. Thank you.
Thank you. And Scott.
Sure. I'm Scott Sear. I'm from Idaho National Laboratory. I'm a system administrator there. HPC sysadmin. I guess we're looking at different ways to collect data analytics about energy, and I'm one of just a few sysadmins that are looking at this. So that's about it.
Okay, thank you. So I mean, the whole idea of this breakout session was to somehow mimic the hallway talks or coffee talks you would have at any conference, which we didn't have for quite some time. So we somehow felt that this interaction between like-minded people is somehow lacking, and so we created this discussion group here during the workshop to facilitate this. But obviously it's just 4 people. This is a very well, how to put it, could maybe a bit well, let's say I thought it would be more people to join in this, and then we would discuss some of the questions I posted before and on the SurveyMonkey. So I'm not sure whether they still make sense. Did any of you actually have a look at the SurveyMonkey, or should I read the questions and the results to you?
I didn't have a chance to look at it, so I wouldn't mind hearing the questions. And
okay, maybe I'll just briefly share my screen. I think I have the results for the ODA part here. Okay, can you see this?
Yep.
Okay. Yeah, so basically I had 4 questions. So if looking at the results, I mean, there weren't many respondents in the first place. I think it was, where is it? 7. Okay. Right. So one question I was curious about was, or maybe we go through the list in the order, like the ranking here. So the first one would be the bottom one. So I mean, there's in fact plenty of sites working on ODA, and they all develop their own solutions for monitoring and also for analyzing the data. And I was really wondering whether there's an opportunity to work together. So within the ODA team in the last couple of months, what we did, we had these so-called brown bag presentations. So we had people from different sites come in, present what they are doing in terms of ODA, and maybe also doing some live demos on how it works and how it looks like. And I thought that was very interesting. And even before that, like a couple of years ago, I think it was in 2018 maybe, we started out with this global site survey where we asked the major HPC sites what they are doing in monitoring and also in analysis. And I think we didn't even coin the term ODA before that. We only used it afterwards. And it was kind of intriguing because looking at the data we got back from the survey, it looked really like everybody was building the same data pipelines with similar tools, and yet they would be very site specific. So I mean, there's lots of usage of Kafka, for example, as a data bus, and transfer protocols like MQTT being used. Then what you often will see is InfluxDB as a database, and then of course all sorts of data analysis frameworks you would also see in other big data applications. So stuff like now I don't even recall it. Like Apache Spark and other tools, and of course people are also using stuff like Jupyter Notebook, so like the usual tools, but also being used in other domains. And already back then we really wondered whether there's an opportunity to work a bit more together and maybe standardize so that you could plug and play different components of the data pipeline from different sites, or the sites would concentrate on a particular part of this pipeline. So in order to somehow join forces and make life easier for everyone. I mean, one thing we also discovered during our discussions was that it's really hard to find talent for these kind of activities. I mean, literally anything that's related to data analytics, the job market is really empty, and since many of us have are working for public funded institutions, salaries are usually not competitive with the market, so it's really tricky to find people and also to retain people. Okay, that was a lot of talking from my side. Do you have any thoughts on this? Can you still hear me?
Yes, we can still hear you.
Okay. Okay, maybe just take one step back. Maybe we can briefly talk about what each of us is actually doing in terms of ODA or monitoring. Is that a good idea? Okay, so maybe
I think that sounds fine. I feel like I was in a lot of those meetings, so I feel strange to kind of talk about things that have already been talked about for
that. Sorry, I didn't get that. What do you mean?
Right, since I've been involved with some of it already, so I don't have anything new to add.
Yeah, right. I mean, of course, you are regular to the ODA team meeting, so you pretty much know what's going on, and I think I also have an idea what you guys are doing. Not sure about the others here. I mean, Scott, maybe do you want to talk a bit about what you're doing? I mean, you said you were looking into the energy monitoring and similar stuff. So does it mean you don't have anything deployed yet, or?
Well, I guess maybe we have some, very primitive systems in place. We collect data into ganglia, kind of, site-wide. We've had tools. We've had, like, say, Bright Cluster Manager that does a lot of data collection, and but that's just for one cluster, right? So we kind of like this site-wide methods. We're looking at collecting data with Performance Copilot. I guess this is just on the data collection side. We do have a kind of a sister group that does data analytics that probably could help us make use of all the data. But and we do have some expertise in our group too. But we haven't, I guess, gone down the road very far. I guess that's where I'll leave it for now.
Okay, so remind me briefly, the Performance Copilot, is that an Intel tool? It sounds familiar.
It's an open source tool that will collect all kinds of information on nodes, memory utilization, CPU, and such. All the kind of metrics that you might be interested in, power. Yeah.
And that's mostly for the host, or do you also get data from, say, PDUs and the cooling infrastructure or anything like this?
That would just be the host. We do get some. We haven't kind of aggregated the data from, say, our PDUs and cooling doors and such. That's a place we want to go. We've been a little thin on personnel, so we haven't been able to make the progress that we'd like.
Yeah, that sounds familiar. Yeah, I guess that's also somehow how we started out with our own development, because we were a bit unhappy with the integration of the different domains in the data center operations. I mean, historically, of course, we have commercial tools to monitor and to manage the cooling plant and so on, and then another one for the power distribution, and of course, then there's the widespread iSinger and other system monitoring tools that collect all the data on system health, and then people are using performance analysis tools on their jobs to also get in-depth information on what the application is really doing. Yeah, and at some point we figured that it doesn't make sense to spread this out over multiple databases or even files. I mean, one challenge we would have very often, for example, and it's really a very simple use case, right? I mean, just correlating the power consumption in a computer room or in a data center, for that matter, with the data from the cooling plant, and yeah, I mean, that basically always ended up in exporting the data from the proprietary systems into CSV files and then re-importing it into Excel and then to some sort of shabby manual work on the sheets you have, and then plot the data. And I mean, being a computer scientist by training, I felt a bit odd.
Yes, yeah, we just built the new data center, and so we do have some custom dashboards built for us as we were building the data center that interact with all the controls, kind of control systems. But that's relatively new to us. Before, we were scraping CSV files for PUE numbers and in our old data center. So now some things are automatic, but we do want to I guess, have control over the data and bring it in and, you know, have better insight into different things, not just PUE.
Yes, yeah, and I mean PUE is one of the many metrics, and then yeah, if you don't have full control over how the metric is being computed, then it's also not very useful. I mean, there's many ways to trick with PUE computation. So yeah,
we had 3 different PUE numbers at one point for different purposes, and different people wanted it calculated differently. So yeah, I agree.
It's funny. It's a very simple metric, but still very hard. Okay, and we have more people joining. So, who is RK Reno? You want to introduce yourself? Ah, Randy. You can also turn on your mic if you want to. Say hello. Okay.
Scott, while Randy's not, let's see.
He's sitting in a server.
Okay, great. Hey, Scott, are you part of the ODA team? Are you a member of the ODA team? Michael, did you already?
I'm starting from 0 here,
okay.
But I do have an interest.
Michael, maybe we can, Randy, actually, Scott, do you work with Randy? Because I know he's been to your site several times.
I don't know of Randy, so.
Okay.
Yeah.
All right. Well, I know he has some contacts at your site, but yeah, I mean, Michael, I think we'd be interested in hearing what you guys are doing at the team. We have these kind of breakout sessions, or rather brown bag sessions, where people come in and just describe what they've got.
Yes, I mentioned that already.
Oh, okay, great.
Yeah, I mean, I suppose by now we kind of had everybody who could possibly present in this kind of context, but yeah, still looking for more people to talk about what they are doing, right? I think so far we didn't have too many presentations from the European data centers.
No, yeah.
I think really just LRC and Chinica.
And TU Dresden.
Right, yeah.
It would be interesting to hear from Finland. And also, actually, sorry, we Surf Sara.
Yes, we also had Surf Sara, right. Yeah, but they are only tier 2. Right. Talking about Finland, so at ISC, in a MODA workshop, then that's the monitoring and operational data analytics workshop that is on Thursday, so that's June 2nd. There will also be a presentation by the guys from CSC in Kajani on the Lumi system and what they are doing in terms of monitoring and then data analytics and so on. It might be interesting to join that if you have a chance. Also, I'm not entirely sure. I think the workshops usually they don't have the hybrid format. I think they are in person, but I do know that they offer Zoom at least for presenters. So I'm not sure that they also make the Zoom available.
They just announced this morning registration category for virtual. So that is, yeah, they have a full registration. They are going to do a hybrid.
But only for the regular, the main conference, not for the workshops, did they?
Oh, maybe not. I didn't notice. Yeah. You know, I had a discussion. I have a topic that I'd like to bring up based on yesterday's keynote. So I'm really interested in this ML, and where ML fits in our matrix, in our framework. Is ML always predictive, or is ML diagnostic?
Well, I suppose ML can be anything you want it to be. I mean, at least if you listen to people talk about it, right? Maybe I just briefly put up the matrix here. Not sure whether everybody's aware about what you're talking. I mean, Kathleen probably is. I mean, we bothered people in the ODA team enough with the framework. Hold on a sec. Can you see my slide?
Yep.
Yeah, so maybe just for everybody who's not aware, so this is this so-called conceptual ODA framework. So basically, it's a mix of two already existing frameworks. So on the one hand side, there's this 4-pillar framework for energy efficient HPC, which basically has the pillars on infrastructure, hardware, software, and applications. And then there's another framework that's widely used by Gardner and other consultants, which is the 4 types of data analytics. And then basically the 4 types are descriptive analytics, so really what happened, and this is mostly about data processing and dashboards. So then there's diagnostic, why did something happen? So this is about root cause analysis and debugging, and predictive, looking into the future, what will happen. And then prescriptive is what should I do about it, and yeah, maybe also about optimization and control theory. So yeah, so basically the X goes from hindsight over insight to foresight. So the predictive and the prescriptive are more about doing stuff in the future, whereas the other one is really looking at what happened and then analyzing what happened.
So you're saying ML can fit anywhere. It's sort of not even on this matrix. It's just yet another dimension.
Yeah, I'm not so sure about the descriptive. Actually, we have the other matrix here as well with the samples we found in literature. So that for descriptive, I'm not sure whether there's much use of ML, but at least for diagnostic, you can for sure use it to cluster, for example, nodes in a system according to some performance characteristics. So I think that's diagnostic. Then of course in predictive, well, you can also use ML to predict data. So we had a use case at LRC as well, for example, where we used ML to predict temperatures of compute nodes and then use this data to control the water temperature in the racks. So kind of a proactive approach to increasing temperatures, so to speak. Yeah, and then for prescriptive, actually I'm not even sure about how we would use ML in prescriptive. I mean, this is really about turning knobs on a system level or on a software level, right?
Yeah, it's really talking. I actually think that I don't, you know, I'm interested in what you guys have to say, because I wonder if it isn't another dimension that just allows you to script. What is ML? ML, there's the learning part of ML, right? Just going in and going through all the data. That sounds a lot like diagnostic. Sounds like it fits clearly in diagnostic.
Yes, but I mean, yeah, it could also be predictive. I mean, training from the data to use it as a prediction model.
Well, but that was the next step. There were two parts to, one was the learning, and then what was the second step? That he described, like 70% of the resources was spent on learning and 30% was spent on what?
Yeah, you got me.
Anybody else remember? Kathleen, do you remember from yesterday's talk?
No, I don't remember.
Well, I could find out. Do you get what I'm asking, Kathleen, here? Is this making any sense to you?
I think I kind of get what you're asking. I don't think I have words to put it into.
Yeah. Hold on, Michael. I'll look at the. So there, okay. So let's just take the case of machine learning for the one I know best, which is, machine learning for self-driving cars, right? So there's this whole process where a whole bunch of data is collected, right? And then it's ultimately installed in taking us down a rat hole. Hold on a second here. Whoa, I'm looking through this presentation from yesterday, and it was pretty, a lot of hardware stuff, wasn't it?
Well, I mean, this is from the guy who wrote books on computer architecture, so
Yeah.
I didn't even know that he was working at Google these days. Yeah, but I also have to admit that I don't have first-hand experience in machine learning. I mean, I used to work with a PhD student of mine, so he was very clever and did lots of the software implementation in our framework to allow for machine learning on the data we collected. But to be honest, I never really grasped the details.
Oh, okay, well, maybe the reason that I was asking Michael is because we had said, we were interested in ML as a team. And so I just assumed, I've been assuming that ML sort of was in the diagnostic realm. But then when I started I know that optimization, though, is, I understand the difference between. So.
That is correct. It's my understanding. And Claudia or Kevin, if you have anything to add that.
Maybe we should, we did see, Michael, you've got something going on in the background. I think somebody
That's
does.
Kevin. Kevin is not
Oh, is it
muted.
Kevin?
Yeah.
Kevin, can you mute yourself? I don't know how to mute him there. Oh, sounds good. Okay. Anyway, thank you, Kathleen. I don't know why my computer was showing Michael's. Okay, so so again, we sort of said we want to go off and understand ML. We do have that presentation that we saw from NREL that, they've actually, they're saying they're doing ML at NREL, right?
That was the presentation about the outlier detection and so on, wasn't it? What
Yeah,
they have to do
anomaly
with
detection.
HPE.
Yeah.
I think that's basically clustering what they did. And I think also HPE is working on something very similar for
Yeah, HP is working with them, and they're doing the work at NREL. They're the ones that are.
Yeah, no. What I meant was that they're also using clustering for another use case, for energy efficiency optimization of applications. So basically similar to what GeoPM is doing by setting power limits on individual CPUs or applications. So basically, when they are memory bound, you can also reduce the CPU frequency because you're mostly waiting for memory anyway. And I think they're using clustering to analyze the application characteristics, and then depending on which cluster an application falls into, they set certain parameters for CPU and memory frequency.
Yeah. Yeah, I think ML has both the diagnostic and predictive. I think it spans both of those. I think it's the scraping of data, and then understand, and then sort of, what does that mean? I think it includes the what does it mean too, which would be the predictive.
No, predictive is not what does it mean, is it? And what does it mean is more the diagnostic, isn't it?
Predictive is okay, so maybe it's just purely diagnostic. I don't know. Masaki, I know this is hard for you, but I'm interested in what you think about this.
Sorry.
Do you
sorry.
use ML?
Yeah.
Machine
No.
learning?
So, I would like to try machine learning something to our operational analysis, but our ODA approach is very low level, so I don't have exact something to explain here.
Yeah.
Sorry.
Yeah, thank you. And Kathleen, do you know of any machine learning for operational purposes at Livermore?
I'm not sure. We're not using it for the sonar aspect currently, but I think it is one of the things we would like to do.
And Michael, remind me, are you guys using machine learning?
Not really. I mean, as I mentioned, we have this use case where we predicting temperature on compute nodes to control the cooling loop in the rack. I mean, yeah, this had a machine learning component, but yeah, ever since Alessio left, we're not working actively in this anymore. I mean, we're looking to hire somebody new, but I mean, we also discussed this, I think before you joined, really one of the major difficulties is really finding talent to work on these tasks. I mean, anything related to data analytics, the job market is really empty, and everybody else is paying much more for such talent than we can afford.
I see. Did you have to buy special tools for machine learning, the special software?
No, that was something we developed in-house, and it was also based on other open source frameworks. So yeah, we're strong believers in open source. We try not to buy proprietary stuff.
And Chinica and NREL and also, if you remember, Sandia, you know, there was that Boston University PhD student doing work that he, you know, 2 years ago at the workshop, he reported that they were doing ML. So really, then the number of sites that are doing ML for ODA includes, again, Chinica, maybe definitely NREL, or they say they're doing it, and a little tiny bit at Sandia.
Can you remind me what Chinica is doing? I don't recall it.
Well, they said they've been saying it for a while, anomaly detection, that they've been using ML for anomaly detection.
Yes, that's true. It's actually funny. So Alessio, who used to do a PhD with us before he joined LRC, he worked at the University of Bologna, and I mean, they are closely connected to Chinica, right? Yeah, and then he actually worked on anomaly detection in HPC with them. So I think the work they're reporting was really the stuff he did as an undergraduate student.
Yeah, I bet it is. I mean, they've been reporting it for a long time. It's been at least 4 years. You know, that I remember them. Yeah, I don't know when he did it, but I don't think they've done a lot more in that regard.
No, but I mean, it's funny. I mean, I also phrased it as a question for the Survey Monkey. I mean, when people talk about ODA, I think everybody thinks of machine learning and artificial intelligence, when in reality, what the sites are doing is mostly visual inspection. And everybody you talk to, I mean, they want to go ML, but yeah, for one reason or another, they don't.
Part of it is perhaps experience. So what AI, because AI is ML and ML includes DL. So it kind of is an understanding of what neural nets mean. So, you know, the biggest opportunity, in my personal opinion, is a lot of the people that are writing the code right now don't have a solid understanding of statistical significance in even understanding it. I mean, if you ask, because I've done this at conferences, what is your standard error? And what is your confidence interval? And for 4 years, those questions by during most presentations have gone unanswered. They just don't know what that means. So part of the opportunities, the people that are actually writing this code, they're capable of writing great code. I'm not questioning that at all. Is understanding what the inference outcome is, because now we've changed from how confident are you in that 90%? Are you 50% confident? Are you 90% confidence? So confidence interval in terms of inference output is critically important. So that then starts to drive what kind of technique are you using in terms of your neural nets, because the image processing, CNNs and DNNs probably there's area for that. But in what I'm finding pragmatically is LSTMs and SNNs, spiking neural nets, offer huge potential benefits and bring high confidence in the outcome, the inference outcome of a result. That is, you can imagine you're monitoring, you have an acoustic sensor placed on a number of different manifolds as an example. Let's say you've got 10,000 sensors on a manifold in your HPC. You start to see noise, a perturbation, an anomaly using LSTM, long short time methodology in a deep learning. So over a long time, you've got this baseline, if you will, but inside of there, you're going to see these perturbations, because that could be startups and stops, or cycling of on and off, or scheduling of on and offs. But all of a sudden, when you look at these short-term durations, you're seeing more a statistically significant deviation out of that. So what you can then begin to say is, what potential locations are these happening? And you might say, oh, it's happening in this area. It's relative to Iraq, for an example. So that would be an example of LSTM. Spike neural net might be when these loads are turned on, we're seeing this anomaly, and that could be that the flow down through a manifold is actually being suppressed for some reason. Whether it's a design, particulate, a number of different things. So these are some of the techniques that statistically, or not having that type of background, make it a challenge. So what a lot of this is, in my opinion, is simply using machine learning to do a more efficient or faster calculations than we used to use using fuzzy neural nets. Sorry about my expressing myself.
No, that was actually very insightful, and yeah, I mean, to be honest, I only got half of it.
So let me give you an example. So about 25 years or so ago, when I was at Seagate, I developed an algorithm that allowed me to fingerprint. We had 3 different vendors that were providing spindle motors to disk drives, right? And I developed an algorithm. I said, you give me 10 motors and I'll tell you with more than 95% confidence which vendor those motors came from. And it took me 15 seconds for the algorithm to run, and it was greater than 95% confident. So simply the cage frequency, the skew and kurtosis of the cage frequency of the bearings of those spindle motors of each vendor was significant enough that I could identify, or the algorithm could identify, which vendor it was.
Okay, so, and the example you just mentioned about the sensors on the manifolds, I mean, is that an actual example, or is it just a potential use case?
It's a scaled version of an actual implementation. There's not 10,000.
Okay.
But in a large data center, you could have that, and it doesn't necessarily. It could be a combination of accelerometers, acoustics. So it could be different sensors, types of sensors, and that's what makes it so interesting, is understanding. Because trying to use one technology to do measurements, you want to have a certain amount of confidence in that something is changing. So an acoustic and accelerometer could be different types of technology that increases your confidence in what signal or what you're actually observing. So instead of having a 90% confidence, you might have a 90.9999, a Six Sigma type of confidence in the outcome.
I see. Yeah. I mean, this also is kind of an example of the outlier detection. We mentioned also, for example, what HPE is doing. I mean, they're also looking on long-time monitoring data, so they can actually detect outliers, right? I mean, one thing they also mentioned, for example, was what the human eye usually doesn't see in visual inspection of the monitoring data is slow change over time. Like, right. I don't know, like some valve clogging up or whatever. I mean, whereas the outlier detection might be able to resolve that.
Well, and this is where, like I say, you can imagine that all of your pumps, for example, have a certain skew, and suddenly you notice that skew is deviating, right? Now, how much could be what the kurtosis function of that is, could be an indicator of saying something is starting to happen, right? Which would allow you to take action before anything. So that's why I say, Natalie, it's kind of diagnostics may become something of the past, because now, in a sense, we're able to see these things happening. I like to use this in autonomous vehicles, the trolley car. So they, you have to make a decision between crashing and killing yourself or crashing and killing people. Well, my belief is that through sensor fusion, it would be smart enough to know that, hey, I don't even want to go down that path because I would have to try and make a hard choice. So I'm going to actually use this route to not have to expose myself to that potential. So now you can think of all these sensors, different types of sensors that is, even work scheduling, getting information from a work scheduling, so you understand what's going on, fusing that with other aspects, other sensors within the system or area, meaning the physical building, and you can start to say, hey, this is what's happening, or you could be integrated to your environment, saying, we have a lightning storm coming. We know that this area is vulnerable to EMI. So let's shift our workloads in the event that something does happen, a transit of some sort. We don't have to worry about it because those systems are not necessarily offline, but running at a lower utilization.
I'm not sure that's a very popular use case, or something people are looking into.
Just hypothesizing.
Right, but I mean, also the what you mentioned earlier about all the sensors and so on. I mean, isn't it also what pretty much all the mechanical engineering companies are now looking into, like predictive maintenance and stuff like this? I mean, that goes down the same route, doesn't it?
Yes.
No.
So now it becomes, what are the biggest opportunities? We don't want to look at something's trivial. What are the big opportunities? And that's essentially what HP is doing, is they're saying, what are the big opportunities? How do we bring that into our algorithm, in manage that aspects of it versus something trivial? But it's these kind of these corner things that you can also monitor, because it could be an interaction then that is the root cause of something.
Yeah. Yeah, and I mean, but eventually it really boils down to finding the talent to implement all of this. I mean, as you mentioned, many people who are working with but actually I think most of them are really working with already established frameworks, and then they throw all the data in, and amazed by the results they get out, and they don't have any understanding of the statistical details of what they are doing, right? I mean, that's one thing. And then also many, and those people who are actually good in the data analysis part, they don't have the background knowledge. And
understanding what ground truth is, right? What is the ideal system versus what are you now observing?
Right.
That's where I think that it could be extremely helpful, is taking some of these key points, especially in terms of sustainability. What are the key pain points? Use that data, get that data, and use that as a federated machine learning approach, so everyone has kind of the same baseline in terms of these key considerations. And then, then you can take that as the starting point, saying, oh, I'm going to set my sigmoid function at this level, in that kind of that closed loop feedback, remember our PID controllers. So in a sense, each one could then tailor what their feedback is, if you will, in terms of importance. So the shell is a 7 hidden layer neural net solution. But then you can put set attributes inside of that for your specific use case scenario, if you will.
Going back to my question about machine learning and where does it fit, thinking about it a little bit, looking at his presentation, first of all, at David Peterson's presentation from yesterday, the keynote. He talked about training and inference. I finally found the words. So those were the two characteristics. And then I did a quick search on that, and I found that, I did ML, training, inference, and it looks like those are pretty classical steps in machine learning. And they clearly fit in the diagnostic and prescriptive, and what's the other one, Michael? Diagnostic, and what's the one that sits on top of it? Predictive. Okay. Yeah. Predictive. Yes. Okay. So, but now I'm thinking about what Randy's been saying. And I do actually think that when I asked you about the tools, I do actually think that there are specific kinds of tools for ML that are different from what we might use, but I'm not sure. That's why I'm going to ask you guys. I mean, this whole idea of the network, then, does machine learning, is the implication of machine learning some sort of a way of going through all the data? And maybe even the inferences are made differently. So, 25 years ago, when we wanted to go search through lots of data, we used a database, right? A structured database. And, today with machine learning, we have different models, mathematical and computational models for searching through the data. And so I think that I'm asking, is that, can that characterize what how ML would fit in our model? Is just a way of doing diagnostic and predictive. Because Michael and Kathleen, and I mean, all of you guys are at least doing lots of diagnostic work, right? So how come you don't call it machine learning? I mean, I know that Berkeley does tons and tons of diagnostic work with all their data. I don't know that they use machine learning to do it. I think they just use standard old database analysis.
Natalie, can everyone see what I'm sharing?
Yes. we can.
So this is a playground. You can actually go out, you can start to explore what these are. It's a little toolkit, playground.tensorflow.org. And so the part of the, Natalie, when you're referring to that is there's structured, unstructured, and semi-structured data. So that's the data over on the left-hand side. That's the data ingress. Now, unstructured is literally you're mixing words and numbers together. That would be unstructured data. So when a lot of the startups, for example, they're saying we only can deal with structured inputs. That is the data ingress when they're doing this as a service. So then on what's called over on the right-hand side, what's called the output, that's the inference outcome. And that's what, and then of course, inside of there is a number of hidden layers. So what I'm thinking is that this basic structure that we see right here, a maximum of 7 hidden layers. So there's the first input layer out here, and then there's the output layer on the right. So inside of here, we could do everything we really need most likely with 7 layers. So we could say that we could come up with an input of features. What are the key input features, and what are you trying to what are the key outputs that we're looking at? So this in a sense could potentially be a template that is shared in an open forum in terms of looking at some sort of attribute configuration. And I'll post this in the event that you want to go play with it. I'll just post that in the chat so you can go look at it on your own.
Yeah. Have you guys been getting these broadcast messages from me, by the way?
Yes, we have.
Yes.
Okay. Because I am going to close in 2 minutes. But thank you, Randy. That is really interesting. That's cool. And it's consistent with what I was just saying about the neural network being the way. It's sort of the underlying methodology that's being used. Again, the mathematical and computational models that distinguishes ML from other kinds of.
Yeah, and so if you could imagine that there's a
Functionally
way,
equivalent. Yeah.
There is a way of using feedback, if you will. This 2 neuron over here, you could actually have a feedback loop to these 4 neurons, and you don't necessarily, this top one doesn't have to be connected. I mean, you can add more layers inside of there, but you don't necessarily have to have, and this is part of the design considerations, this top one would not necessarily have to be connected to all of these 6 neurons at the next level.
Sorry to interrupt, folks. Quick time check, top of the hour. Everyone else is waiting in the main room.
Okay. All right. Thanks, Sid. Okay, guys, I'm going to close out. We'll join you in a sec. All right. Thank you.
Thank you, guys.